Now here's an example then on coordinate geometry and the equation of a straight line. And if there's any parts here that you're unsure of, you can always just fast forward them to the work solution. But essentially what we've got here is the line L1. It has an equation 2y minus 3x minus k equals 0, where k is a constant. And we're given that the point A, which has coordinates 1, 4, lies on the line L1. And in the first part we've got to find the value of k. So for part A then, how are we going to find the value of k? Well, since 1, 4 is a point that lies on the line, it must satisfy that equation. In other words, when x is 1, y is 4. So if we just write that in here, that when x equals 1, y equals 4, we can substitute these two values into the equation and work out what k is. So if we substitute these values into the equation, we therefore have 2 times y, 2 times 4 in other words, minus 3x, so that's minus 3 times 1, minus the constant k equals 0. So we've got 8 minus 3, which is 5, 5 minus k equals 0, add k to both sides and you get 5 equals k, or therefore k equals 5. So there's your value of your constant k. Now in part B, we've got to find the gradient of the line L1. And we should be familiar with the form y equals mx plus c, where m is the gradient of any straight line. So what we can do now is rearrange this equation to make y the subject. And we'll substitute k equals 5 in here as well. So if I was to add 3x to both sides and add k, or 5, to both sides, I would therefore end up with 2y equals 3x plus 5. Now if I divide both sides by 2, I'm going to get y equaling 3 over 2x plus 5 over 2. And so therefore the gradient of L1 is the coefficient of x. The gradient is going to be 3 over 2. So therefore gradient of L1, okay, just put this as an intro, okay, equals 3 over 2. Alright? Now, we next have the line L2 passes through A and is perpendicular to the line L1. And we've got to find an equation of L2, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers. To do something like this, I would want to draw a sketch. So we'll have our y-axis here, and we'll have our x-axis, say, here. So we've got the point A, 1, 4. So imagine that we go 1 across here, 4 up, and that's our point A at 1, 4. Now we had our line L1 which passed through A. Remember it had a gradient of 3 over 2, and it would intercept the y-axis at 5 over 2, 2.5. So therefore it's going to be something maybe looking like this. A line coming through there and out the other side. So that's the equation of the line L1. So L2 is going to be a line that's perpendicular to this. So we're going to have a line something like this, going through A, and it's a right angle here. So how am I going to get the equation of the line L2? We'll just label it L2. Well, we're going to work off the form that any line has the form y equals mx plus c, but that's not necessarily very useful when it comes to working out this. I'm going to use the form y minus y1 equals m bracket x minus x1, a form that we should be familiar with by now. x1, y1 is a point on the line we know that it's the point A with coordinates 1, 4. And m will be the gradient of the line. Well, we haven't got that gradient at the moment, so I need to get it. I know it's perpendicular to the L1, so that gradient of L2 must be minus 2/3, the negative reciprocal of this, because the product of the gradient should always equal -1. So we know that the gradient, gradient of L2 must equal the negative reciprocal of this, so it'd be minus 2/3, so that when you multiply this with 3/2 you get -1. So therefore we've got the equation of L2, therefore let's just put a little intro here. Equation of L2 is such that it is y minus y1, we take y1 to be the 4, equals m, the gradient, which is now minus 2/3, multiplied by x minus x1, and x1 is the 1 there. Alright? Now we've got to get this in this format here, so we're not to have any fractions, for instance, because a, b and c are integers, so I'd want to multiply both sides by the 3. And if I do that, I'm therefore going to have 3y, minus 4 3s are 12, minus 12. If I multiply this side by 3, it's just going to leave me with minus 2 times x minus 1. And if I expand that, I'm going to get minus 2x and then plus 2. So to get it in this form now, I've got to lead with an x term. So I'm going to add 2x to both sides and subtract 2 from both sides. So what that's going to leave me with, if we can just squeeze it in here, is 2x, and then we've got the plus 3y, and then we've got minus 12 minus another 2, so that's going to be minus 14, and that equals 0. So I've squashed it in there a bit, just purely because I would like to keep everything on the same page. So okay, hope you can see that. 2x plus 3y minus 14 equals 0. Now for the next bit, we're told the line L2 crosses the x-axis at the point B. So that's got to be this point here, the point B. And we've got to find the coordinates then of point B. Well, we've got the equation of L2, and we know that at B the y coordinate is 0. So all we've got to do is just put this equation, substitute y equals 0 in here. And if we do that, we're going to have that 2x minus 14 must equal 0. And if I add 14 to both sides, we're therefore going to have 2x equals 14. And if I divide both sides by 2, we're therefore going to have that the x coordinate of B is 7. So the coordinates of B must be 7, 0. Alright, 7, 0 for that. Let's just put that in now, 7, 0. Now, in the last part, E, we've got to find the exact length of AB. And to find the exact length of AB, we think of using Pythagoras Theorem. Let's just draw a triangle in here now. Okay, we're working off this triangle here, this red triangle. So we know that the distance AB, if you were to square it, AB squared, would equal the sum of the squares of the two shorter sides. And this side here is 4 units long, because A is 4 units up from the x-axis, so it's going to be 4 squared, and then plus, and this horizontal distance here is going to be the difference between the x-coordinates, 7 minus 1, a total of 6 units there, so that's going to be plus 6 squared. So Pythagoras' theorem, hypotenuse squared equals the sum of the squares of the other two shorter sides. And if we work this out, we've got 4 squared is 16, 6 squared is 36, and that comes to 52. So therefore AB is going to be equal to the square root of 52. And we're told to give it as the exact length. If you were to do the square root of 52 on a calculator, it's irrational. It's an infinitely long recurring number. So we've got to give an exact value. So we break this up into the fact that this is the same as 4 times 13. So it's the root of 4 times 13. We can square root the 4. It's 2. Can't square root the 13 so easily. So the answer, the exact value, is 2 root 13. Alright. Well, there you go. Bit bunched, as I say here, but I hope that's given you an idea of how to do this question.